Welcome back to Business Mathematics 2, MA 1203. I am Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So today we are going to talk about system of linear equation. Okay, in short, linear equations. The first talk we would like to review, and we are going to talk about how to solve and find the solution of linear equation, a set of linear equation that have two variable and two equation. Let's start with the review. So if a slope of a line, if a line that passes through y1, x2, y1, the slope is given by m equals y1 minus y2 divided by x1 minus x2. Okay, what about the vertical translation of a line? So if I have equation of a line like this, y equals mx plus c, what is the difference between y equals mx plus c with y equals mx? When c is positive, y equals mx plus c is just a vertical displacement by c units along the y-axis. Okay, yeah. So that is what we usually call by vertical translation of a line. An equation of a line with slope m with passing through x1, y1 can have this kind of formula: y minus y1 equals m times x minus x1. But we have another kind of representation of equation of line, that is ax plus by equals c. Also, okay, yeah? Two parallel lines share the same slope but have different vertical displacement. Like this, y equal mx plus c and y equal mx. It has the same slope but have different vertical displacement. That is what we usually call two parallel lines. Finding intersection point between two lines. So if you are given two lines, ax plus by equals c, maybe you have dx plus ey equals f. How do you find intersection point? Very good. To find the intersection point, I have to find the solution of the two linear equation x and y that satisfy those two equations. Okay, yeah? And this is a word of caution. Careful, the line y equals minus 2x plus 1 is the same as the line 2x plus y equals 1, and it's the same as the line 2x times k plus y times k equals k. This equation times k. K doesn't equal to 0. Okay, this is just the same line, the same linear equation, the same linear equation. So the first one, we are going to talk about a system of linear equation that is a Gauss and Gauss-Jordan elimination methods. So what does it mean if we want to find intersection of these two lines? Don't forget, we want to find the solution in this. Geometrically, we want to find the intersection of two lines. Okay, yeah? You can use lots of methods. But algebraically, to find intersection of these two lines, I have to find the solution such that x, y, I have to find x, y that satisfy the first and the second equation. Okay, yeah, finding it is the same as finding the solution of the equation. The solution 1, 1 is the solution of this. Why? Because if you substitute this into the first equation, it applies. You substitute this into the second equation, it satisfies also. So it satisfies both of the equation. So this is called the solution of these two equations. Are there any other solutions? Okay, in this case, the intersection is only 1 point, that is 1, 1. Try drawing the graph. Okay, what about this one? X plus y equals 2 and 2x plus y equals 4. Okay, how many solutions do you have? Don't forget, this is the same as this. This is the same as this. This is because the first equation is multiplied by 2. So you have 2x plus 2y equals 4. So in short, this is the same equation. So I want to find x and y that satisfy this one equation. I want to find intersection point between one line. So the intersection point, so the solution should be all of the point in the line. All of the point in the line. So how many intersection point? How many solution do you have? Infinitely many solution. Okay, yeah? And what about this one? This is x plus y equals 2, 2x plus 2y equals 3. If I this multiply by a half, I have x plus y equals 3. Don't forget, x plus y equals 2 and x plus y equals 3. This is two parallel lines. And two parallel lines doesn't coincide. So you do not have intersection point. So you do not have any solution here. Okay, yeah? So you do not have any solution, you do not have intersection point. So in general, I have ax plus by equals e, cx plus dy equals f. How many different solutions can you have? Yeah, or equivalently, how many intersection points can you have geometrically? So there can be one solution correspond to one intersection point, or there can be infinitely many solutions correspond to infinitely many intersection points along the line. Or you can have no solution correspond to no intersection point. And this applies for any linear equation with any number of equations and with any number of variables. Okay, the question now is how can I differ all of these three cases? How can I differ all of these three cases? So a powerful method for this is called a Gauss or Gauss-Jordan elimination method. I think you have all seen this implicitly while you are working with this system of linear equation using elimination method or substitution and elimination method at your maybe junior or senior high school. Okay, yeah. Let's look. So first of all, I want to introduce three operations that is called elementary row operation that can be applied to two equations, these two equations, to find the solution of the equation. So first, multiply a certain row with a number. So if I multiply one of this with a number times 2, don't forget it still gives you the same line. It means it still gives you the same set of linear equation. So the solution doesn't change. And the second, if multiply a row with a number k, the third first. If you exchange the row, the solution doesn't change also. The solution doesn't change also. And last, if I multiply a row with a number k that is doesn't equal to 0 and add or subtract it to another row, the solution doesn't change also. The solution doesn't change also. Let's have a look at an example. Here, I have x plus y equals 2 and I have 2x minus y equals 1. So I want to find the intersection of these two lines geometrically, or algebraically, I want to find the solution of these two linear equations with two variables, or we usually call system of linear equations. I can multiply the first row with 2 and the second row with 1. This is what usually you do when you use elimination method. Okay, yeah? And then we can subtract the first row from the second row. Okay, yeah? And put the result in the second row. Subtract the first from the second. So 2x minus 2x, that is 0x, minus y minus 2y become minus 3y, 1 minus 4, it become minus 3. Okay, yeah? And then I have minus 3y equals minus 3, thus y equals 1. And then by doing back substitution, y equals 1, to the first row equation, you have 2x plus 2 times 1, that is 2, equals 4. So you have 2x equals 2. It means that x equals 1. So the solution gives you x equals 1 and y equals 1. So the intersection point is 1, 1. Okay, yeah? So what about we can write this down in a more elegant way using this kind of notation. Okay, yeah. So we put this into what we usually call augmented matrix form. So we look at the coefficient. This is 1, 1, 2, 2, minus 1, 1. So I have put this. Okay, yeah. You multiply the first row with 2, this one. 2 times R1, don't forget this equivalent as this. It means if you change this, the solution doesn't change. The solution doesn't change because you use the elementary row operation. And elementary row operation doesn't change the solution of the system, solution of the linear equation, this linear equation. And then R2 minus R1, and you put the result in R2. That is the first component. R2 minus R1. 2 minus 2 is 0. Minus 2 minus 1, minus 3. 1 minus 4 is minus 3. So you have this one. Later on, I can multiply the second row with minus 1/3. So you have 1, 1. Okay, and this means 0x plus 1y equals 1. So you have y equals 1. What does the first row mean? It means 2x plus 2 times y is 1, equals 4. It means 2x equals 2 and x equals to 1. So I have the same solution, the same intersection point. Okay, but I'm using a much more simpler notation, and that is what we usually call the elementary row operation. You can multiply, you can exchange row, and you can multiply something and add or subtract to another equation. Okay, let's look at the second case, x plus y equals 2 and 2x plus 2y equals 4. So in the augmented form, I wrote down as this, and I have R2 minus 2R1. This is 2 minus 2 times 1, that is 0. 2 minus 2, 0. 4 minus 2 times 2 is 0. So you have this. Oh, okay. So it means you do not have two equations. Instead, you just have one equation, that is x plus y equals 2. Okay. And so how many solution can you have? Infinitely many solution. Because you want to look for x and y that satisfy this equation. Very, very lots of 0, 2, 1, 1, 1.5, and so on. Okay. Okay. Infinitely many intersection point, infinitely many solution of the system of equation. What about this one? I can put on this, and it will become this. What does the second row means? What does the second row mean? It means that 0x plus 0y equals 1. Are there any x and y such that if you put it in here, it will give you 1? No. So in here, there are no solution. Exactly. This is a parallel lines. Parallel lines doesn't have intersection point. Okay, how can I look at this? Just look at the augmented matrix after you do elementary row operation. Okay, so in general, there are only 3 cases to consider. One solution, infinitely many solution, and so no solution at all. And we can differ those cases just by doing some elementary row operations. Okay, next we are going to talk about solution to general n variables and equations. Thank you.